Hello everyone, how are you? I hope you all are doing fine. By the way, welcome to my YouTube channel Physics in a Nutshell, and as always, if you're just new to this channel, subscribe to my channel, and if you like my way of teaching, hit the like button. By the way, let's start the class. By the way, we are still discussing the lesson that is what? Work and energy, which is our chapter 11 of our class 9. By the way, in the last class, what we have discussed so many things. From the concept of what? Work, right? Then we have to understand the concept of energy. Then we actually study different forms of energies, right? And how work and energy actually related, what is the unit of energy, what is the unit of work, right? Among all the form of energy, we actually take one main energy that is known as what? Mechanical energy. And of that mechanical energy, we actually say that there are two types of mechanical energies are there in a mechanical energy. One known is what? Potential energy, and another form is what? Kinetic energy. Right? In the last class, we have actually discussed the kinetic energy. Now, what was the kinetic energy, or what is the concept of the kinetic energy? When an object in motion, or what we can say, when an object having some amount of speed or attaining some amount of speed, that object, okay, which is in motion, is going to have some amount of energy. That energy, when an object is going to be in motion, is known as what? Kinetic energy. Right? We have to deduce a relation of that kinetic energy. That is what? Ek equal to what? Half of mv square. Right now today we have to actually deduce, or actually to observe what is the potential energies. Right now, today's topic is going to be what? Potential energy. Okay, this is the one form of energy belongs to what? Mechanical energy, right? So to understand the potential energy, we have to consider certain examples. Okay, first take the example of rubber. Okay, we know that we can actually stress a rubber. Right now, when we are just stressing that rubber, we have to apply some amount of force. Right now, and when we are just applying that force, with that force, that rubber is what? Elongating. That means what? The rubber or certain portion of a rubber is getting displacement. Right now, that means what? We are doing some amount of work with that force. Right? Right now, but once we leave that rubber, what is actually going to happen? It is going to come back to its original position. Right now, but before that we have this amount of work. That work then is going to be what? Stored as energy. Now, what is that type of energy? Question mark. Again, same thing happens with the what? Spring. We can actually what? Elongate that spring or stress that spring, but once we release it, it is going to what? Come back to its original position. But to only certain limit. That limit is known as elastic limit. After the elastic limit, what actually happens? That stressability actually reduces, or ultimately it goes. Okay, so what is the main reason behind that? When we just stress that rubber, we did some amount of work. Right now, so when that work we did, we know that the amount of work done is known as what? Energy. That work done is stored as what? Potential energy. Okay, if that energy is not used in what? Moving a certain object. You can consider one example, that a toy car in which we have to what? There is a key. Okay, first we have to rotate that key. Once after a certain point, that if you just leave that key, what is going to happen? The car moves. Okay, when we are just moving that key to a certain point, at that point that energy, or that is the work that we did, is stored as what? Potential energy. Right now, once we release that key, that potential energy transferred to kinetic energy. Okay, because that energy is used in what? Moving in that object. Again, we know that whenever an object in motion, if that object having some amount of energy, that is energy is known as what? Kinetic energy. Right now, so that is the main fact. So what we can say from here, when we do some amount of work, is stored as energy, and that energy is transferred to as what? Potential energy, unless and until that energy is used to move that object. Right? So that is the main thing about the what? Potential energy. And this potential energy actually based on the what? Position of the object and the whole configuration. Okay, so that is the main thing about the potential energy. You have to understand the concept of the what? Potential energy. Okay, so that means what you can say, the energy stored, or the stored energy. Okay, if that energy is not doing any kind of what? Movement or motion, so what always known as what? Potential energy. Okay, that is the main thing. Right now we'll say, what if there is any kind of relation of the potential energy with height? Okay, whenever we lift certain things to a certain height, is there going to be any kind of relation with with potential energy? We'll check that. Okay, so that is going to be our next topic. So this is our next topic. What this topic is actually saying, the potential energy of an object at a certain height. That means at a certain position from the ground. Okay, so see, always remember one thing. Whenever you have to pick up something from the ground, we have to apply what? Force. Okay, and when just we are applying force, with that force, that object is going to have some amount of displacement. That means what? Force into displacement is equal to what? Work done. And we know that work done is known as what? Energy. Right? So whenever we are just displacing that object, or whenever we are just doing that work, right, we are just doing that work against the gravity. or again the gravitational force or the gravitational pull, right? Consider this is the ground, okay, ground. So we have to leave that object, or one object which is at here, we have to leave that object from to this side. Okay, this is the total amount of height. Okay, you have to leave that object from here to here. Give some name to this position A and it is B, having height difference h, right? Whenever you have to actually leave that object from A to B, we have to do work, right now? Against what? Gravity. That means in this direction you have to do work, but where is the direction of the what? Gravitational pull? In this direction. That means a negative direction where we are actually doing work. But we are not going to consider the directions or the negative sign we are going to give. We are just actually doing it, right? We are just going to consider that we are just doing work against the gravity. That's why whenever you have to lift something from a ground, okay, from a certain ground, from certain level, okay, it is going to have a certain amount of displacement, right? And with the displacement, what is going to happen? We are going to do some work, and that work done is known as what? Energy. And that energy is known as what? Potential energy due to what? Gravity, right? Known as what? Gravitational potential energy. Okay, gravitational potential energy, right? So if we have to give the definition of the gravitational potential energy, what we have to say? Gravitational potential energy is that type of potential energy where we have to do the work in lifting an object or raising an object from a certain level to another height, okay, and doing the amount of work in against the gravity, right? So what we can understand that to get the concept of the energy, first we have to do work, and that amount of work done is known as what? Energy. And here that amount work energy is known as what? Gravitational potential energy. Again, we can actually construct a relation with the energy with that height. It's quite simple. Okay, now we are going to do that. Okay, here I have considered this is the ground. Okay, this is the ground. Okay, I have lifted an object which is having mass m and to an height of h. Okay, so mass equal to what? Mass equal to m. So what is the displacement here? It is the displacement of what? H. So what is the displacement here? Displacement here h. Now what is the acceleration? Acceleration due to gravity is what? Z. So acceleration is known as what? G. So whenever we just lift that object to a height h, we have to do what? Work done. Or simply or reversely, what we can say, whenever you have to lift that object to the height h, we need force, right? Now to lift that object, that force will be what? Mass into acceleration. Here what is the mass? M. Now what is the acceleration? G. So what is the force? F equal to what? mg. Now what is the displacement is given? h. So what is the work done? Work done equal to what? Force into displacement. So here what is the force? mg. And what is the displacement? h. So what will be the total work done? mgh. Alright, now again we know the amount of work done is known as what? Energy. Here what is the type of energy is? Potential energy. What you can say? The energy is transferred to what? Potential energy. So here we can actually write EP, E for energy, P for potential. That means the what type of energy it is? Potential energy. So what will be the formula? EP equal to what? mgh. So that is the formula for what? Potential energy due to relative with height. But here certain facts are there. Whenever we have to discuss the height, okay, it always based on the level or the ground, okay, from where the height actually measured. This is one example, right? So we can consider one more object, okay, from here to here, right? This is given the name m1, it is given this name m2, and it is having some height h1, it is height h2, okay, ground 2, it is our ground. It is look like that. If you don't know physics or if you don't know how to measure the height, what you will say, or some other person is going to say that yes, that object is going to have what? High amount of height actually, or mass amount of height. But it's not that so. We have to measure the heights always from each respective ground. Okay, for that object, each ground is going to be what? This one, not this one. Okay, or for this one, this m1 object, its respective level is going to be this one. Okay, so whenever you have to measure the height of an object, its height always should be measured from its respective ground. Okay, so that is the fact. And for every cases, the height is not going to be same, or the levels are not going to be same. For this room, my level is my floor, and for the other rooms, maybe it is having different amount of floor. The floors maybe at different heights. So these are the facts. Certain different facts are there. So it doesn't matter what type of actually heights are there of that floor, but whenever you have to measure that object height from a certain place or from a certain level, you have to always measure the height from that level only. Okay, you cannot measure the heights from a different amount of level or from some random actually levels. Okay, it is specific for a specific object. Okay, that is the main fact. Again, one more specific thing you actually observe that. See, here the height is this one. If I draw an object like that, okay, just wait for a minute. Okay, this is one object and this is the object M1, 2. If I draw like that, okay, like that, okay. So this is the ground. Tell me one thing. Is there, in which case the height is going to be higher? In which case? What do you think? Right? The answer will be in no cases. In both the cases, heights are same. Okay, that means what you can understand from this thing that heights always measured vertically. That means we cannot measure the heights like that. Okay, or what you can say, we cannot measure the distance that it actually covered as the height. Okay. The displacement is going to be the height, and displacement definition was what? The shortest distance between 2 points. The what is the shortest distance? This is the shortest distance. This is not the shortest distance. Okay, this is not the shortest distance, right? So that is the main fact. So whenever we have to measure the height, it should be always the vertical direction, not that kind of right or left side directions are there. Okay, we just have to measure the vertical direction or the shortest distance between what 2 points. Okay, so that is a main thing that we have to actually understand from the what potential energy. Okay, whenever we have to actually object placed at a certain height, we have to consider this kind of things are there, right? So that is the main thing about the kinetic energy we have to understand last class, and today in this class we have to understand the concept of the potential energy. So this is the concept of the kinetic energy and potential energy. Now we will move towards our next topic. Okay, our next topic is going to be about law of conservation of energy, right? I actually repeated this thing in many videos, maybe in the last videos too. But to understand this thing, we have to consider certain examples are there, right? So what kind of examples are there? First, we can actually take that our plants, okay, produces food for us, okay? So where from they get the energy to produce food? Because from food we get the energy, right? First question, right? Secondly, what actually happens? We know that solar energy, right? For that, what we do? We actually place solar plates above our home. So what actually happens? That solar plates, some solar rays actually fall. So what actually happens? That solar energy gives us what? Electric energy. That is one thing, right? So again, those cells which we actually use in the torchlight or the batteries, what actually happens? From chemical energy, we get the what? Electrical energy. So all these examples, what we are actually getting there, we are getting some amount of specific energy from a pre-existing energy, and that pre-existing energy again getting from what is further pre-existing energy. That means what we can say, energy was not created, not destroyed. Okay, that is known as what? Energy conservation law or law of conservation of energy. What law of energy conservation says, or what law of conservation of energy says, that energy neither can be created nor can be destroyed. Okay, it can always change from one form to the other form. Okay, but the whole system's energy or the energy of the whole system remains constant. Okay, that means if we consider a certain event and we are just actually observing that energy is releasing. So what we actually understand that at that event or before some certain specific phenomena, the energy before and after remains same. That means as a whole, what you can say, the whole system energy is going to be what? Constant. Okay, we can actually understand it from a simple example. We are going to consider it. After that, from that example, you are going to understand it well mannered. Okay, you are not going to have any kind of doubts on that thing. Okay, you have to still understand that. For that, what we are going to have? So, what is that example is going to be? We are going to consider an object which is at the height of h. Okay, at the height of h. Consider this is a building. Okay, having height of h, and that object is placed at the top of the building. So if we now consider that if that object at rest, okay, here it is at rest, okay, you equal to 0, that means the speed is going to be 0. So if the object is at rest, that means its speed is going to be 0. So here the kinetic energy will be what? Kinetic energy will be what? 0, na? So here the total energy will be going to be what? Its potential energy, because it is going to have maximum height, it will be what? mch, right? Now what we are going to consider that the object now starts falling to the ground. So what is actually going to happen? different positions from the top of the building, it is going to have different amount of energies. I will consider 3 different points, A, B, and this is the C position. Okay, so now you just look carefully. When that object starts falling to the ground, what is going to have? It is going to attain some amount of speed, right? So consider that this is the what? Half of mv1 square, right? And here it is having potential energy mgh1, right now. So what that thing is going to be? Here the mgh1 is going to have different, a little bit high. So and half of mv square little bit less because it just started falling. So it has started attaining speed. So here the thing will be what? Potential energy is greater than kinetic energy at the position A. Right? Now we will check from A to B or at the position B. Here the potential energy is going to be what? mgh2. Right? And what will be the kinetic energy? Half of mv2 square. Here we will consider that since it is almost middle of the building, we will consider that just for the convenience we are actually considering that potential energy is almost equal to what? Kinetic energy at position B. Okay, now we are going to consider the C, right? Here it is almost mgh3, right? Right now obviously. And here it is the half of mv3 square. Right? Now look carefully at this level. Okay, at this level height almost 0 becomes 0. There is no height, but it is having maximum kinetic energy. So the total energy is going to be what? Total energy is going to be only, it leads to what? Half of mv square. That is the kinetic energy. Like the similar case, here the total energy was what? Here the total energy was what? Potential energy m of gh, right? So if it actually satisfies the energy conservation law, it actually satisfies the energy conservation law. So what we going to happen in every cases, though in some cases potential energy is going to be what? Higher than kinetic energy. In some cases potential energy is going to be equal to kinetic energy. In some cases potential energy is going to be least, okay, compared to the kinetic energy. But as a whole, the whole system is going to have total energy is going to be what? Constant. Okay, that is potential energy is mgh plus what is the kinetic energy? Half of mv square is going to be what? Constant. Okay, it doesn't matter how much potential energy it have, how much kinetic energy it have, but the total system is going to be what? Constant, or the total energy of the system is going to be what? Constant. So that is nothing but what? Law of conservation of energy. So what this energy, law of conservation of energy, says that the energy neither can be created nor can be destroyed. It always transforms from one form to the other form, but or as a whole what you can say, the total energy of the system remains constant. That is nothing but what? Total energy, or the law of conservation of energy. Okay, now our next topic is going to be what? Rate of doing work. Okay, rate of doing work or work done, we can say that. To understand this topic, okay, we have to understand one specific thing. Okay, tell me one thing, if you consider a specific work, can that work done by every people at the same rate? Okay, now since I am using the word rate, you have to understand that whenever in physics we are using the word rate, that specific thing is going to be vary with time. In the lesson motion, in the first lesson that we actually discussed in the what? Motion, we have said that the rate, whenever the word rate, whenever we are going to use in physics, that rate is nothing but what? Related to what? Time. Okay, here since we are dealing with what? Rate of doing work, we have to change the work with time. That means what? Just consider one example, right? You know that in many games or many sports there is an example, that powerlifting competition or weightlifting competition. Okay, tell me one thing, does every people or can every people do the same thing at the same time? Obviously not. See, consider one example that we have to lift a 20 kg object. Okay, with me there is another person. Okay, consider I am having high amount of power. Okay, so I can lift that object so easily with what? Less time. So if I tell the other person to lift which is having less amount of power, what is going to happen? He have to suffer to lift that object. That means what? He is going to lift that object what? But with high amount of time. That means what? We have to understand that power is inversely proportional to what? Time. right? That means what? With time increases, power is going to decrease. If time decreases, power is going to increase. We will check that. Okay? How is going to get the relation? But whenever we have to change the work done with time, we are going to get one more new relation. That is known as what? Power. That means power is nothing but what? Work done by time. Okay? When we just vary the work done with time, we are going to get new term. That is nothing but what? Power. Okay? So here power P, work done is W, time is T. Okay, that is the fact. So what we are actually getting that from here, if we consider the time constant, we are going to get that power is directly proportional to work done. Okay, if you consider that work done is constant, what we are going to get from here, power is inversely proportional to what? Time. So what we can say that with time increasing, power is going to decrease. With time decreasing, power is going to increase. So that is the main fact about the what? Power. So what we can say from here, the definition of power as the rate of doing work, okay, per unit time, or the rate of transfer of energy. We know that work done is nothing but what? Energy. So what you can say, the rate of transfer of energy is known as what? Power. Now you have to check what is the unit of power. So to understand that, we have to understand what is the unit of what? Work done. Its unit is what? Joule. What is the unit of time? Second. That means Joule second. Okay, its specific unit is going to be what? Joule second. At that Joule second is known as what? Watt. After the name of a scientist known as what? James Watt. So that Joule second is known as what? Watt. Okay. So what is the unit of power is watt, right? So now we have to understand the concept of 1 watt power. So if there is a question, what is 1 watt power? You have to say that when there is a work done 1 joule per unit second, or you can say when there is a work done 1 joule in 1 second, the power is going to be what? 1 watt, right? So that is the main concept about the what? Rate of doing work. So till now we have to understand lots of things, starting from concept of the work to what? How the work done changes with time. Okay, so we have to travel lots of things. So now it is time to actually what? Conduct one new quiz competition, right? And along with that, we have to announce the names of the winners of that last quiz competition. Okay, so just wait for it. In the last quiz question, we have actually given one question that I have actually said that one force is uniformly applied, right? That means constant force is continuously applying, okay, on an object, and that object actually move from A to B, right, which is having separation of 10 meter, right? And force is Fc, that is the force is constant, and again return to its what? Original, that is A position. Now I have actually told you what is the work done. Here see, whenever you have to calculate the work done, we need what? Force into displacement, right? Here what is the displacement? See, first it moved from A to B, then again return to what? B to A. That means what? Initial position and final position become same. Whenever the initial position and final position becomes same, in that case, what will be the displacement? Displacement will be what? S or D become what? 0. Doesn't matter what will be the force, if the displacement is 0, the work done is going to be what? F into 0 equal to what? 0. So that is the correct answer. Okay? So that is the correct answer. Here work done will be 0 since the displacement is here is 0. Okay? Again, I give one criteria to this quiz competition, that only the first 3 winners is going to be the correct winners. Those who have given me the correct answer. But here I have modified one thing, that I am going to make 2 categories, one from the boys side, one from the girls side. So what we are going to do? I am going to consider 3 winners from the boys category and 3 winners from the girls category. Okay, so along with that I am going to announce the winners name. Okay, so now I am going to announce the name of the winners. Okay, so from the first, that is the girls category, the winners are, first let me announce the name. The first winner is, or the first place that have considered is nothing but what? Bandita Soikia. She actually considered the what? First place. And second place is taken by Amajita Rahman. After the third position was taken by Nikita Kolita. So big congratulations to all of you from the girls category, that you have actually given me the answers correctly and you just give me the response correctly. Okay, so thank you for that too. Okay, and now from the boys side, the first winner is Devabrat Kolita. After that, the second winner is Anur Deka, and the third winner is what? Rakibul Hussain. Okay, these 3 are from the boys side, and that former 3 are from the what? Girls side. So many congratulations to all of you. Okay, you have win this quiz competition. As I actually said that there will be what? Prices for you too. So don't worry about that too. Okay, I will actually mention the prices, so don't worry about that. Okay, so now today I will give one more quiz competition. Okay, just wait for that. I'm gonna write that question in a board. Okay, just wait for it. This is my today's quiz question. What this question is actually saying that two bodies A and B of equal masses are kept at heights h and twice h respectively. Now we have to calculate the ratio of their potential energies. Okay, in this video I have actually explained the concept of the potential energy. Then we have actually calculated the relation of the potential energy with heights. Use that relation, but before that watch the video properly. Then you will actually understand the concept of the potential energy. Then you will be able to solve this question and give me the proper answer with proper reason. Okay, I need the answer with proper reason. So this is my today's quiz question, and along with that, this is going to be our end of this video. Okay, and end of this theory part of this lesson. Okay, we almost covered 4 lessons of our physics part. We are now almost 1 lesson away to complete this whole physics syllabus of the class 9. So we have actually traveled lots of days or lots of things we have actually traveled. So for whatsoever reason, if you have liked the video, please hit the like button, and as always, if you have not subscribed yet, just subscribe to my channel. Okay, it always gives me encouragement to make lots of videos like that. Okay, so till then, just stay safe, stay healthy. Okay, we're going to meet in the next video of a new lesson. Okay, but before that, before starting a new lesson, okay, I actually forgot to tell you, before starting a new lesson, we're going to solve some problems. That is a numerical problems for your final exam. So for those exams, we are going to solve certain numerical problems, and so with that numerical problems, we are going to get some new knowledge of this lesson too. Okay, so after the completion of that video, that is after the completion of the numerical problems, then we will start our last lesson of physics. Okay, so till then, stay safe, stay healthy. We'll meet in the next video. Bye bye.